Hello and welcome to the wide world of physics. We had a question. One of our viewers asked why steam will burn your arm faster than plain old hot water. It's a very simple one in the sense that it's principles that we already know, we just have to apply them separately. In doing so, we need to look at the three main states of matter. So, I have an array. We have ice. We're dealing with water, nice and simple. You can do this at home. You can see this very simply. So, big ice cube, we know that ice is solid. Solid, as a state of matter, means that the molecules are bound tightly together, they're sitting next to each other, and they're vibrating, but they're not moving. There's no room for them to move, which is why you can't put your finger through the table. Very simple. However, when you change that state to become liquid water, you can see quite easily that dipping your finger into the water will generate motion. You can move those particles out of the way. You can displace the water by putting something in it, but more importantly, you can dip your finger into them. So you can move those molecules out of the way. They have more space. Now, more space means that if you give them a bit of a stir, they will have kinetic energy. So, if you stir those water molecules around, you can feel them, you can feel the current hitting your finger. It's like dipping your hand into a moving river. You will feel those water molecules and they will be colliding with your hand. Now, when you make hot water, when you've boiled water, you can see that that hot water has more energy. You've given it heat, so you've given it more energy, and therefore it has more motion. More heat, more energy, more kinetic energy, more importantly. So to give you a better view, we have ice. Nice solid ice cube. Right? This is still just water, but it is now solid. It's starting to melt because it's rather warm. But the point being, it's still solid. It's actively converting into liquid because it's gaining energy. It's gaining heat from the surroundings. It's gaining heat from the air in the room. Which is why, if you have a very cold beverage, it will then become room temperature if you leave it out long enough, because that heat will transfer into the cold drink. Same thing works in reverse. So you have liquid, you have more energy in it now, because it's gone from solid to liquid, and therefore it is gaining energy. You have given it more energy, especially now that it's roughly room temperature. So again, if you stick your finger in, you can see very easily that you can move the water out of the way. So those molecules are further apart. They're further apart, very much so, than the solid. The solid are tightly packed in there. They can't move. Like I said, that's why you can't put your finger through the table. But in doing so, when you give them more energy, you give them more kinetic energy. You give them more range to move. Now again, when you have hot water, if you take the hot water, you've given it more energy again. And you can see there's steam coming off of this cup. Now, that steam is the water going into gaseous form, the third state of matter. That state has the most energy. You're giving it enough energy for it to physically escape. You're giving those molecules enough energy to physically escape the surface of the water and literally fly off into outer space, as far as the water is concerned. So they're flying off into the room. That's what that steam is. So you can see the steam coming off of it. You can see that motion. That's that energy that's coming off of the top of the water. Now, again, we're talking about energy. So more energy means more speed. So if you stick your finger into hot water, which I don't recommend, but yes, it hurts. But if you have an actively boiling pot of water and you put your hand over it, again, not recommended, but all of those molecules that are coming off of the top have a lot of kinetic energy. They have a lot of velocity. They have a lot of speed. And they're coming right at your hand. It's the difference between holding your hand out the window of your house and feeling the air come by, and then holding your hand out the window of a car as you're driving along. That force of those molecules hitting your hand is what you're talking about. Now, if you have to think about it in reverse, look at it this way. Instead of the car moving and your hand hitting the air molecules, your hand is now stationary, but those molecules have velocity, they have kinetic energy, and that energy is now being transferred into your hand. It's colliding physically with your hand. The more water you boil, the more energy it's going to have. The hotter it gets, the more energy it will have. Therefore, the more kinetic energy it will have, the more it will impact your hand, and therefore it will hurt more. Thank you very much for watching. If you are enjoying these videos, by all means, please remember to like and subscribe below.